Hello, everyone. Good evening. Welcome to some training on drone mapping. I'm going to be joined by Nate Howard here shortly. He's actually in Colorado for some training, and he texted me he's running about 5 minutes late, so he'll be jumping on in just a bit. But if you are here, jump in the comments, say what's up, let me know where you're coming from, and I don't know, throw a little fun fact about yourself. While we're waiting on Nate, I can tell you about myself, and we can get going in some of these comments here. All right. Today's title, probably the longest title of a webinar we've ever done. It is how engineers, surveyors, and construction pros are using drone mapping to work faster, safer, and smarter. Long title, but basically we're going to talk about how drones are being used in engineering, specifically civil engineering, and then some surveying and construction, which kind of goes along with civil engineering. What's up, Carl, from the Hawaiian Islands, California? Man, it's like middle of the day over in Hawaii, probably, huh? California, New Jersey. All right. Probably gonna be a small crew here today, and I apologize. Hopefully my internet holds up. I was having some weird connection issues earlier. But when Nate joins us, he's gonna dive into a lot of what he does personally. But let me tell you about myself first, in case you were unfamiliar. I'm curious. I think we basically only sent this, I think, to people who were not already associated with Drone Launch Academy in some way. So I'm interested. Have you ever heard of Drone Launch Academy before? Do you have any idea who I am before you saw this webinar? I think we were just running ads to new people, but I'm curious if any of you have already seen us before. Maybe you're on our email list or maybe taken other courses. Let me know in the comments if you're new or if you've heard of us before. But my name is David Young. I'm the founder of a company called Drone Launch Academy. Can't see my shirt. I'm also repping the shirt. And we started off as a drone company doing FAA Part 107 test prep training back in 2016 when that test first came out. So my background is more in aviation and FAA stuff. I was a licensed ground instructor. But as we started that company and people started using drones, they're like, well, hey, what else can I do with this? And, what do I do with this license now? And so we started making additional trainings, more like professional development type trainings. And we made stuff on cinematography. Then we got into roof inspections, some photography, some real estate stuff. And then we moved over to more of the data side and started creating trainings for photogrammetry. So we had a photogrammetry fundamentals course, and most recently created some advanced mapping and 3D modeling courses. So that's more geared towards the surveyor, engineer, professional, those who maybe are using drones in a bit more of an advanced way, who are going to be using coordinate systems and absolute accuracy and those types of things. So Nate is actually one of our instructors for one of those courses. But for me, I've been in the drone industry about 9 years, maybe 10 years now. Drone Launch Academy has had over 50,000 individuals now go through some of our courses. Again, we have a whole bunch of different ones with different instructors. Our goal there is we go out and we find professionals who are doing this actively in the field and get them to teach what they know. So that's the goal there. But I got my private pilot's license back in 2007, remote pilot certificate in 2016, right when that first came out. And I think I got this back in 2015, my advanced ground instructor certificate. So I've been in aviation a long time. I haven't really flown that many planes. If you know anything about me, not a huge fan of piloting small aircraft because they crash more than I had thought originally. But yeah, all right, let me see what you guys got going on here. So Dallas, Texas, New York, California. All right, cool. So we got Tim, construction superintendent, licensed land surveyor with Part 107. All right, David. Nice. Okay, so that's a little bit about me. Nate should be on in just a minute, but I'm going to pre-introduce Nate. Okay. So Nate is a survey manager at Kiewit. I'm not sure if you guys have heard of Kiewit before, but they're like a huge construction engineering firm. They do a lot of, or at least what Nate's involved with, is a lot of the heavy highway civil engineering side of things. So he's a survey manager there, helps with their survey teams and all their GNSS equipment and control and all the stuff that actually makes things go in the right place and get built in the right spot. So he is a certified survey technician level 3, but he's done so many different things in construction. He's been in construction for over 2 decades, and as doing survey tech type work. He's done power plant projects, rail construction, mining stuff. So he is one of their, I guess Kiewit doesn't have an official drone program, but he's one of their UAS subject matter experts. So he's in charge of several states when it comes to surveying, as far as like surveying techs and a lot of their geospatial equipment and a lot of what they do with drones. So he's flown around the country. He's gone to Australia to meet with Propeller. They're like a big software company that does a lot of drone data processing. So he's got a lot of experience on a bunch of different platforms like Wingtra, a bunch of different DJI platforms. So he's flown a lot of different types of drones, brings some good perspective and experience to this. Melbourne, Australia. Melbourne, maybe I think they said, listening while I'm working. All right, I was just talking about Australia. Propeller's an Australian company. Let's see. Petunia Scott, Part 107 since 2018. Powerline inspections, survey tech previously and now. Chattanooga, Tennessee. I love Chattanooga. Great city. Taking some courses, Aerial Photo Pro, and some drone mapping and modeling. Excellent. Cool. All right. Well, I'm glad you all are here. I could tell you, let's talk. Nate can join us when he gets here. He said he's running behind. There's some traffic getting back to his hotel. He's again in Colorado doing some training. He was nice enough to be able to jump on here. So it's actually like, I guess 6 where he is. So probably close to the end of his workday. Oh, cool. All right. And there's another one, RJ. Just guys, Part 107, construction project manager. Sweet. So I'll tell you what I know. I know a lot. I would say this, a little bit about a lot of things. So I rely on Nate for like the actual day-to-day operations of everything he does. But when we made courses, I went out there and spent several days with Nate, spent several days with different geodesists and different people doing teaching survey control. So the nice thing for me is I get to absorb all this knowledge. And then I've also done some projects with Wingtra. So I've tested out some of their equipment and their GNSS gear. I actually have one of they came out with these new things. This is not what we're talking about tonight, but they came out with these new tripod GNSS receiver setups for some of their like ground workflow stuff that they have. So it's pretty cool. You set these guys on your control points. They're like really low to the ground. So anyways, worked with them on some stuff. So I've learned a lot about surveying geospatial world over the last year or two, more than I have in the past. So I can talk about this, at least from the drone perspective and that workflow and how that works. But let's talk about this for a second. Does anybody know what this means, 4IR? And if you were here, we did a presentation on similar topics about 3 months ago. So if you're here for that, you'll know what this is. But what do you guys think 4IR stands for? Maybe you've heard of it. So it's just to kick us off. Let me know. Sometimes there's a little delay, so I'm going to wait. Anybody? Any guesses? I'll wait another 10 seconds, and then I'm just going to tell you. 3, 2, 1. All right. 4IR stands for the Fourth Industrial Revolution. Hey, at least you appreciate getting in there for a guess. Infrared. IR does stand for infrared, so good guess. But when people say 4IR, there's a fourth industrial revolution. What the heck is fourth industrial revolution? Well, we've had industrial revolutions throughout time. The most recent one was the third, which is sort of the invention of the internet and computers, and that changed the way we worked, right? So if you imagine even architects or accountants, let's say early 1900s, they're doing everything by hand. They're keeping accounting records by hand. They're drafting by hand, a lot of manual work. So this new big technology comes along and changes everything, right? Computers, now we can have things like QuickBooks that automatically keep all the accounting records. We have things like, CAD softwares to be able to do drawings and different engineering and architectural design in a computer software. And that takes the place of a lot of what you would do manually by hand. And a lot of people are like, oh man, it's going to disrupt so many jobs. Well, the fourth industrial revolution is more around the digitization of the physical world and AI. So RJ, pretty close with AI there. So this was a definition that I could find that I thought summed it up pretty well. Fourth industrial revolution, Industry 4.0 is a new era of development with digital and physical and biological systems converge fundamentally transforming industries, economies, and societies. So the convergence of the physical and digital worlds. And this is what we are seeing a lot right now. And it includes drones. So I want to say drones, unmanned aircraft, UAS, all this. I'm talking about the same thing. It involves that. So one big thing that's happening right now is instead of people doing a lot of work by hand, and too, with AI, a lot of people are taking jobs that were normally manually processing. Now AI can knock a lot of that stuff out. Similarly, drones can do a lot of the things that required manual work before, especially in surveying, and can speed things up a lot, right? So typically, if you're using it right, you're not necessarily going to replace people with it, but you're going to make them more efficient so they can do a higher volume of things, maybe greater accuracy. And we're going to talk about some of that today. So that's the fourth industrial revolution. And what's going to change, which industries. So today we're going to be specifically talking about engineering, construction, and I mostly mean I guess civil, but maybe environmental. I don't know about mechanical, maybe a little bit with or structural. Mostly civil. It helps the most is what I've seen. And then construction, and then definitely surveying. All right. So those are the industries that I think it's going to change the most, and that we've been seeing at least the highest adoption rates for. So I just pulled a few quick reports here. So have you guys ever heard of Drone Deploy, the software Drone Deploy? They make a photogrammetry software that can do a lot of processing, pretty helpful software. I'm not here to talk about it necessarily, but they did a report last year called The State of Reality Capture. And reality capture is just another definition for digitizing the physical world. And I'm assuming if you're here, you probably already are familiar with photogrammetry and what that is. If you're like a surveyor or engineer, if you're not, I can briefly explain that for you. But let me know. Yeah, let me know if you're actually familiar with photogrammetry or not. If you're not, it's totally fine. I can give a quick explanation of it. But essentially, you're taking pictures, tons and tons of pictures of something, feeding into software, and it's turning into either a 3D model or a topographic map, some representation of the physical world that you can measure and accurately put into some type of coordinate system. Ooh, I see Nate popping on here. I'm going to give him a sec to get set up. Give me a thumbs up when you're ready, Nate. But yeah, so while we're talking about this, they did a study and they looked how many people are adopting it. So I'll zoom in here. So they said 60% of enterprise businesses are already using reality capture. And then they said, if you look at companies with 10,000 employees or more, it goes up to almost 80%. Only 20% of companies, this is kind of a weird way to say this, but only 20% of companies with over 100 employees have no plans. With the remaining 20% actively planning to do so, this doesn't add up to 80%. Oh, maybe that's adding up to the 60% here. Maybe that was their definition of an enterprise business. So these are planning to do so. So a lot of people using reality capture. And then as far as people investing in it, 62% of businesses plan to spend more on reality capture that was in 2024, now in 2025. 34% expected to maintain spend. Only 4% of people are going to cut back on it. So basically, people are investing in this technology. The adoption is really increasing. And I've seen that a lot over the last 2 years or so. It used to be where drones were like, well, I don't know about drones, and it seems kind of like a fad, or how do you actually use it? And maybe we'll do it. Just people are kind of resistant to changing up the structure or system they had. But I've seen in the last 2 years a lot of companies adopting drones. Tons of departments of transportation are adopting drones. I'm sure, I feel like probably all of them have been using drones at some point. I had a good meeting. I went to Exponential in Houston. Oh, I'm still here. I went to Exponential in Houston, and I met with the head of UAS for the Alabama Department of Transportation. And they have, I think he said 8 full-time pilots. They just travel all around the state, collecting data and helping with photogrammetry and getting updates and topographic maps and different products for the DOT as they're making highways and bridges. So pretty cool. So a lot of DOTs using them. Tons of construction companies are using them now. Survey firms definitely picking up. So the adoption is there. All right. Nate, are you ready? You want me to put you on now or no? All right. Give me a thumbs up. Here he comes, everybody.
Hey,
what's up,
how's it
Nate
going?
Howard? Good. Thanks for jumping on, man. Got some, sorry, hit some traffic.
Yeah, was currently in Denver right now doing some training with some engineers.
Cool. Well, I already gave your intro back here, but is there anything else?
Perfect.
Maybe you give your own intro because I probably missed some stuff.
Uh, Survey manager at Kiewit. Got 25 years doing surveying, construction, mapping. Started out land surveying, do a lot of design surveying and stuff now. Currently the district survey manager for Kiewit for the South Central District, covering Texas, Louisiana, Arkansas, Oklahoma, and Mississippi. Help out across the company with a bunch of different other survey managers. We kind of work together as a tight knit group and take care of most of the survey in the company. Um, have my food license, have a side hustle as a bakery. Uh, just feel like we got to throw a fun fact in there. But
Nice. Um, give a little bit about what you've been doing with drones.
yeah, so um, we've been kind of on this wingter kick lately. VTOL, vertical takeoff and landing, fixed wing drone flies a little faster, but we've been using that for man. We've got some not just we don't have a lidar on the wing trip, but we are using lidar on a couple other different drones. We're looking at getting a lidar payload for the wing trip. Typically, most of what the surveyors are doing is photogrammetry. We have a digital design group and a geospatial group in house. They do a lot of lidar, mobile lidar mapping, and some drone based mapping as well. We use it for quantity takeoffs, so doing estimates, comparisons, quantity tracking throughout the life of a construction site, construction project, and then also just for planning. Um, it's really changed the game on how we plan and move things around in construction. Being able to see a picture from, yesterday versus back in the day, you're waiting to hire a pilot out and getting flights every 3 to 6 months and paying hundreds of thousands of dollars.
Sweet. All right. Well, thanks for the intro. I was just walking them through briefly some of this in fourth industrial revolution stuff, what that means, how it's changing a lot of things. Essentially, we're just more and more and more digitizing the physical world, putting it into computers and using that for tons and tons of analysis, documentation. And we're talking about adoption here. Some stuff I think you've already been over with us.
There's
All
some
right.
crazy things going on with technology with this stuff. Like it's nuts.
What's your favorite thing you've seen lately?
Man, so there's I think technology and construction and reality capture and some of the not to go off on an AI tangent, but some of the being able to live capture a job site and then AI is being able to vet and compare tolerance issues or installation issues and stuff like that's on the market already. So like being able to get updated maps, quantities, that kind of thing, and then being able to use AI to do something in half the time or like a quarter of the time that a human could do to find issues or errors or it's just fantastic. It's pretty crazy stuff that we're looking at.
Yeah, it is advancing very quickly. Now, have you guys already done that stuff, or are you just looking at implementing it?
So we looked at a couple of them. We're doing some testing with some people, and then I kind of nerd out and follow a lot of that stuff and watch some
Yeah,
videos on that thing. I
nice.
mean, just because I think there's all sorts of, I think, again, I don't want to go off on an AI tangent and get off of drones, but I think like with where AI is going and where it's at now, um, aside from how terrifying it is, there's a lot of use cases, and I think
Yeah,
being able to find ways to implement it and use it to make things faster and better is going to be pretty cool.
yeah, love it. Um, all right, so I'm curious. I think a lot of you have thrown your job titles in here, so we have a couple folks who are survey techs, construction project manager, forensic geographer, surveyor, construction superintendent, a couple people doing drone cinematography. But with all these changes, right, adopting drone technology, other just digital twin reality capture technology. how does that going to change your job? Maybe this is a good question for Nate. So I guess maybe compare it to like, I don't know, 5, 10 years ago. What are like the biggest shifts and changes as far as like what this means for those types of jobs?
Um, I think so. This is a trick. This kind of ties back into AI a little bit too. I think it's a tricky subject sometimes to talk about because I mean, ultimately, one of the things these things do is free up the labor force. Um, and a lot of people look at that as, oh my goodness, we're going to be out of a job. I look at it as let a drone do something that a human can't, and let me put that human problem solving and that kind of thing on smarter, harder problems and tougher things. So I think like that's kind of how I approach all this technology. But I mean, if you look at what a drone does now and can cover versus the amount of area and acreage and a topo, right? It's like we hardly ever topo anymore and get any topographic information. So before you'd have a surveyor out there walking or even just mounting something on a vehicle to go pick up points every 25 foot or whatever. Now you can do that in 45 minutes over 200 acres and get that information back with a drone. So I think that frees us up to have those guys do, like I said, more detailed, more critical thinking type tasks.
Yep. Cool. Well, let's walk through. We were going to talk about, I didn't put the agenda on here, but the goal was, hey, let's walk through sort of how this works. So typically every time we do a mapping training, things can sort of be placed into one of 4 buckets. So typically you got to figure out, you're going to plan. So planning a flight, you got to figure out where you need to fly. And since most of the data capture, the flight part of the drone is automated, a human still has to design and put the parameters in on where the drone's going to be flying and what it needs to take pictures of and how often, and overlap and a whole bunch of different other settings and there's safety considerations. So we'll talk about that and talk about what Nate does for that. Then you got to actually acquire the data, meaning go out there and either take the pictures, or if you're doing LiDAR, run that and capture the returns, get the data you need. Now you have that usually on some type of SD card or some other storage device. Go toss that in your computer. Then you're going to process it either in the cloud or locally, like you're going to let your computer do it. Put all that together to create whatever it is that you're trying to create. So photogrammetry, you're going to create an orthomosaic image or a digital surface model, some type of output, and then, or if it's LiDAR, something different, and then you're going to analyze it. Like, what are you going to use it for? So Nate has a bunch of I love hearing all the different use cases they use it for. Like you said, they do takeoff calculations. Sometimes they're looking at different slopes, safety slopes. Sometimes they're just wondering where all the material is or pipes are or something. So we'll talk about that. What's your data analysis for? And I guess you guys use it. You guys load it up and have a ton of people in there looking at some different. Everybody's using it for different things, right?
Yeah. What's crazy is almost everybody on our job site uses it. Not just. I think a lot of thing is too, like, we talked about this before a couple different times, David, is like originally drones were kind of in survey and mapping with drones was like, oh, cool, we're going to get a 3D map and we're going to figure out some dirt stuff. But like, it's so much more than that. I think the biggest thing is like the whole how people analyze it now, because you're just limited to your imagination. I mean, you've got so much data now that you can do so many different things with.
Yeah. I feel like every time I'm around you, you show me some different stuff. I'm like, oh, this is awesome. Like the one hydrology thing you showed me was like rain simulation. It loads in all the elevation data, and you can say, hey, if it rains for an hour and a half at this intensity, where's all the water going to collect? It's like, oh, it's awesome. All right. So that's the process. So let's talk through flight planning. We've got your course that you put together on some of the stuff, at least that you do for your construction engineering, that we could look at if you wanted to look at like some screenshots and stuff. But why don't you just talk through this and I can take some notes for people. When hey, we are going to be doing a project somewhere, we want some data. Let's say it's the very beginning of the project. Walk us through sort of your process for planning this out.
So, I mean, the first thing I typically do is get just a rough location. And even with all the crazy, super expensive tools and everything we have, we go to Google Earth, right? Here's our project location. Here's a rough size. From there, that kind of gives me an idea. Depending on the drone you're using, X amount of acres at X height is going to take so long to fly. So I'm sorry, I just
What?
realized that I'm in a hotel, and I was like, man, the bed's not even made. There's just like
Like, I can't even see it. If you hadn't said anything, no one would have known.
Hold on. Let me. All right.
I was gonna pull up your this over here for people. So this is your this is the one you use. So there's like Google Earth. Right, that would be like an example of, maybe I make this bigger for people.
Yeah, because a lot of times, like, based on the drone you're using, the rough, I can cover 50 acres in X amount of hours or whatever. So from there, I kind of start with, I like, if you're looking on the screen right now too, on this particular example, we did a much larger job site or a much larger flight plan than we actually needed, right? So that little yellow thumbtack there in the middle is kind of the furthest south end of the project. We didn't need everything all the way out to the east or everything far down to the west or even down further south.
You're kind of like in here.
Yeah.
And
but I like to
see if I can get it zoomed out. There's your like total flight plan that you did.
But I think part of that comes back to, like, again, thinking about analyzation, right? Some people are going to want to know subcontractors, vendors, or deliveries. How do I get into this job site? What's the best path? Especially when you start construction. We're going to close down roads, make new entrances. So having that updated imagery and a little bit of a bigger picture is good. And then too, like, just being able to plan. Because again, if you try to narrow it up to exactly this is my job site and that's it, like, a lot of times that's still not enough. You'll get some warping and some weird things at the end of your project.
Yeah.
Now, if all that's way outside my project, who cares?
Yep. You also look at towers too, because if you're flying drones, normally you're going to be flying somewhere probably between 200 and 400 feet. And a lot of times these towers are kind of in that same range. So talk through some of just what you're looking out for in terms of site planning to make sure you don't hit anything.
Yeah, so Cavill and Mertz, you can kind of see their deal. You can Google them. They've got this super slick, I don't know how often they update it. So again, do not use this 100% for towers. But like, they have a Google Earth file that has like all of these towers across the United States. So it's a real easy planning tool just for a quick, sanity check of, hey, is there anything in the area? It gives you the height, the above ground level, that kind of thing as well. So I like to have them in that Google Earth picture as well to make sure, okay, what do I need to use to make this flight plan? Because most drones and most flight planning softwares on the drones, once you get this KMZ or KML created, so we can go around these towers and whatnot, you can then load that into the drone. So, like, really, Google Earth is a one-stop shop kind of for flight planning.
Yeah. So you're getting all your stuff in Google Earth and also planning your GCPs, your kind of rough GCP location. Are you guys familiar with ground control points? I'm sure if you're a surveyor, you probably are, but if you haven't done much data collection, you might not be. But you want to give the 2-second version on what a ground control point is, Nate?
Yep. My favorite analogy is just imagine a pile of dirt, throw a tarp over it. That's essentially what you're flying. GCPs, ground control points, are nails going through the tarp, pinning it to the dirt. The more of those you have and more strategically placed, the more you can actually get the tarp to conform to what the dirt is doing underneath.
Yeah, so it makes sure that whatever map you end up collecting, it's going to make sure that the map matches the real world point at that location at everyone. So it's going to make sure the more you have, the more accurate your map will be to real world coordinates. So, it's good to plan those out because, again, they was telling me, sometimes people don't think about where they're putting them. They might not forget to put them in a corner over here or some other places. And so your map might be super accurate over here, but if you had never thrown this GCP out here, this sort of third of your map might drift and be off. And this is not a very big site, so maybe this one would be okay. But let's say it was a huge site.
Another common thing I've seen a lot is if you don't do your GCPs and your flight planning at the same time, where you can see them in the same spot, you're essentially going out there with a drone that's got a flight plan in it, and you know, to hope this lands inside that flight plan. So this way you can kind of see, like, based off of what I'm creating and what I'm doing, my GCPs are actually inside of this.
Yeah.
Because we've seen that a lot too, is like people do it in two separate buckets and don't do any sort of overlay.
Yeah, because if your flight plan was here, you know, you're not going to get any pictures of that, and so you know you're not going to be able to tell the software, hey, this is GCP number 3 was this exact coordinate, so it's going to be pointless.
Yep.
So that's sort of your Google Earth layout. Anything else you do? So there's you bring in your KML file, you know, anything as far as like your mission planning with, I guess this is using a Wingtra. When you're thinking about your flight plan and your mission planning, any specific things you're thinking of here, or maybe like drone selection as well?
Yeah, so like depending on like for this project, one of the other reasons we went so large was the Wingtra is kind of overkill for a small project. Most of your drones that have RTK, the real-time kinematic, you know, for using post-process, that kind of thing, have like a 10-minute, 15-minute requirement for the drone to be in the air collecting good GPS signal, right? So the Wingtra, if we had just flown the area that we needed to fly, would have been like a 2 or 3 minute flight. So we expanded that because it covers ground so quickly. It's doing like 35 miles an hour, I think, depending on where you're flying at and the conditions. So we expanded that to get like a minimum of a 15 to 30 minute flight. So I think like that's another thing too, is like depending on what you're doing and what size of project you're looking for, bigger's not always better. Again, the Wingtra is a fantastic drone, but you're talking about $40,000 to $60,000, and it's like, do you really need that for a half acre? Probably not.
If you had a half acre, honestly, you could map that with a Mavic Mini that you can buy for used for $300 or something.
Right. So I think that's super important too, is as you're doing this, is kind of, I don't want to say get a fleet of drones, but definitely know, right, if you get a Mavic Mini and then you go to do 300 acres, you're probably gonna
You'd be there a while.
Yeah. So it's like know the know the minimum maximum capabilities of each drone, because again, we probably have 6 to 7 different drone types now, and depending on what we're doing is which one we use in those instances.
And I get a lot of questions from people about like, well, what drone's the best to use? And if I'm just starting out, what do I use? And this and that. And I always tell people, if you're getting started, you can do a lot. I mean, you're not going to do hundreds of acres, but you can do some decent sized projects. And if you're trying to keep it on the cheap, like let's say you're kind of just getting into this, if you got some budget to spend, you could get one of like the, you know, honestly, if you got like a Mavic 3 Enterprise, like a used one, those are really good. Those are a little bit, maybe you're on the higher end of the starting out stuff. But even if you got like a Mini 3, or like if you can find a used Air 2S, you can use those with Drone Link. You do have to have like an Android device to operate that. That's probably one of the cheaper paths into this, at least to like learn it, and you can actually collect data and do things with it. And then if you're going to really take it seriously, or your, you know, job, let's say you do this for your employer, you can convince them to, you know, invest a little bit and buy some nicer equipment. But that's like probably your baseline starting out. It's like a Mini 3. Because I always get that question, so I figured I'd just address it up front. All right, cool.
I would say too, like going back to like what drone's the best, it depends on what project you're doing, right? Because again, we started out with a Phantom 4, and then, you know, we were on a little 200-acre project that took 45 minutes to fly, so we were changing batteries 3 different times to get that whole flight in.
Yep.
And then we moved on to a much larger project that was 6-7 miles long, and then we had to buy like 15, 16 batteries to be able to fly in one day. And it was like, well, this doesn't make any sense.
Yeah.
So again, I mean, you can do it, but like know the scope of the project you're going for and that kind of thing too.
Yeah. And then shoot, if you're doing like 10,000 acres, maybe it just makes sense to just hire an airplane to go do it at that point, you know?
Yeah.
So there's there's scale all the way from a Mavic Mini to probably satellite data, so just somewhere in there.
Yeah, somewhere in there.
All right, cool. So that's kind of our gear selection. Now you talk about correction methods. So we're getting into some of the fieldwork stuff here. I would flip back to my slides, but I was just going to take notes on them. It's easier just to illustrate if we just walk through here, since we kind of did it in order anyways. So the fieldwork, maybe let's talk about correction. We talk about gear selection and correction methods. So like different like PPK, GNSS, RTK stuff. Again, if you're a surveyor, you're probably going to know about this stuff, but for those who don't, maybe what is, oh, great thumbnail. I promise Nate was real happy during these videos. So he's looking real serious.
It looks like I'm about to yell at you. It's almost like a viral video. It's like about to.
Are you filming me?
Get off my property.
Yeah, exactly. Actually, this is, we're on the property that you saw in the Google Earth file that we went out here and we're collecting data on it. But briefly talk about GPS, GNSS, and when you're doing drone data, having the correction sources and why you need them, maybe.
Yep. So
that's a big topic to kind of try to condense down in a few sentences. But
GPS is technically part of GNSS. So there's different satellite constellations. No, so groups of satellite. Just think of a constellation as countries that own them. GPS is owned by America. Those are American satellites. GNSS is part of the global navigation satellite system, right? So that's like includes China's got some satellites, Russia's got some satellites. Man, I always forget Japan does too. America, and there's
China,
one more.
India.
Yep. So those are the, write down number 2. So GPS, GLONASS, Galileo, Beidou. So those are just different constellations that, so like a lot of times I use GNSS and GPS interchangeably, just because more people are familiar with GPS and just think of that as like satellites.
But then correction sources. So like these are always, the satellite signals are coming in, but there's always a little bit of error. It's not going to be down to, the centimeter as far as how accurate it's going to be, because there's all this stuff that can mess up the signal coming in. So usually you guys go out and have like a really good known point that you've surveyed for a really long time that you can lock in, or maybe you use some, NGS monument or something. But you have that, and then you're receiving information there, and then that base station is comparing how far off those signals are, and it uses those calculations to correct any of the data that the drone is getting while it's in the air to kind of tighten it up and make it more accurate. That's used in conjunction with those ground control points to really make sure the map is exactly pinned down to the coordinates that it needs to be. Because if you're using this drone data with any other external data, like some design file, or maybe you're comparing 2 different data sets, maybe you fly the drone one day and then you fly it 3 days later, you need to make sure those maps are exactly on top of each other. Otherwise, let's say you're measuring like a stockpile of dirt, or maybe, like the curb on the side of the road, and you're like a few inches off the next day, it's going to completely mess up all your calculations. So,
yep. So talking about the, the correction sources, right? There's 2 big ones, really. There's PPK and RTK. Those are really the 2 big ones. So PPK, post-process kinematic, which is, think about it, you go fly the drone and you use some sort of correction source to lock in what it does is it verifies the GPS coordinates inside the drone and ties them into a known location. And then you have RTK, real-time kinematic, which is, think of it as you've got some sort of GPS base unit on site the entire time that the drone is in the air collecting data, and you're comparing those to each other. So you're getting real-time information from the drone, and the base is getting real-time correction information too. And so at the end of your flight, you have your photos. They're essentially, for lack of a better term, immediately processed. Whereas PPK could be, depending on what sort of software you're using, 20 minutes, 30 minutes to 12 hours.
Yep. It's basically when you're applying those corrections to the coordinates that are stamped onto that photo. Yep.
And both have their pros and cons, right? So like RTK, if anything happens to your base while it's running,
Kind of screwed.
no bueno. You can only get data up to that point.
Well,
PBK.
yeah.
I'm sorry. Go ahead.
No. You finish.
I was going to say PBK also. If you don't know how to post process, or if you don't know how to get the right data file, you can't do anything with it.
Yeah. No, I was just going to say sometimes RTK corrections some people rely on like an internet connection to connect to some virtual correction network. So if you're somewhere where you don't have cell service, or let's say the correction source that you're connecting to virtually is kind of far away, like along baseline, it's not as accurate. So
yeah,
cool. Well, we'll keep moving here for time. So you go out, you get all your GCPs and check shots. So check shots are just a way to verify your accuracy.
Snapping these thumbnails. Like, I done told you 3 times to get out of here.
You fly your mission. This is what it looks like. Got a nice checklist. There's Nate whipping up that winged drone. We get that thing up in the air. We launch it, and it's flying itself around. Gathers all the data. You're good to go. Now you've got an SD card, all your data. So now we're going to process the data. So with the wing tray, you go through and some geotags, some photos. They've actually improved that to where it can just do that pretty quickly and automatically now.
Yeah.
But we got some processing scenarios. So this is what propeller looks like on the inside. You want to talk quickly through processing options, maybe cloud versus local, and what you guys do and what you think through in terms of processing.
So there's a bunch of different processing platforms, Pix40, Propeller, I think Drone Deploy does it as well.
Yeah.
A bunch of different things. So a lot of those are cloud-based. You can get desktop versions of them, but it's essentially drag and drop your information, tell it your correction source, upload GCPs, and then you let it cook. And then you get an email notification, hey, we processed this. Here's your data.
Mm-hmm.
A lot of desktop softwares. There's a little bit of work you have to do. Some of them, Pix4D, I think, has a desktop version where you essentially do all that locally instead of putting it in the cloud. I would just say look at the software you're using, even some of the cloud-based softwares. There's the one that I'm not super familiar with, but did a demo on last week, Datamate. You still have to, it's similar to Propeller, except for you have to actually go through and verify your GCPs. Mm-hmm. So like essentially you have to pick through 5 to 6 pictures. Here's the GCP, here's the center of it, and physically move the target like a little crosshair to here's the center of my target, here's the center of my target through 5 to 6 pictures. There's Bentley, super expensive program, context capture, kind of the same thing, where you physically say, so there's, depending on your computer, depending on your rig and your setup, cloud-based may be much easier. If you're running off a Commodore 64, probably not going to do it locally.
But I think this image is a good sort of illustration of what you're talking about. So each one of these little yellow dots is where a picture was taken. Yes. And it's your letter. And then here you can see which ones were your control points, like right here. So it's like, hey, here's what's going to be used to make sure my map is pinned to the right spot on the Earth. And all the flags are checkpoints. So it's basically going to use those to say, okay, your map said that this was the coordinate of this location, but then your actual GPS receiver, like your data collector that the coordinate that you shot said this. Let's compare those to see what the differences are to make sure that your map is actually accurate, kind of comparing it to an outside source of data.
Probably ought to touch real quick on GCPs and checkpoints. Yeah. So GCPs tie everything down. That's what used to create the map. A checkpoint is just a checkpoint. So most of these softwares and processing things are just going to tell you this point checked within this deviation of the map we created. So don't get those confused, because a lot of, we've had some people upload checkpoints thinking that that's what the map was going to get created on, and vice versa.
Yeah, so I'm trying to see if I can pull up so here's sort of your verifying your accuracy and quality report. Let's see if I can find it. So here's, well, those are your GCPs. Let's see if we get to your check shots. Yeah, so here's your checkpoints. So you can see it says, hey, here was your actual coordinates, and then the difference, how far it was off for each one, and then you can kind of add those, get averaged together. Well,
Yep.
sort of averaged, yeah. Cool. So that's your processing. I know we're going through this pretty quickly, but we'll be around for questions too. So you can either upload it somewhere, and they're going to do the process of stitching all those photos together. And that always kind of boggles my mind how photogrammetry works, to where literally just taking flat photographs, and they're able to see the differences between photographs and the change in the geometry from one photograph to the next, because you're kind of changing the angle. Then it matches up all the points in the picture, and it's able to create like a 3D version of what it sees on the ground based on just the flat images, which is pretty wild to me.
It's amazing.
So it takes a while. So if you submit it to a cloud software, they're doing all this work on their servers, and it takes several hours. I've got a computer down here. It's not as powerful as those servers, but if you have something with like an NVIDIA graphics card, usually you can do some processing. I think I did like a 100-acre site, and I just let it run overnight. It probably took like 6 or 8 hours just to do that. So it could take a while. But once you have it back, it's pretty interesting. I also love this little thumbnail down here you got going on. So that's your processing. And then we did planning. You go out there and you fly your site, did the data acquisition, process it all together. And typically you're going to look at this to see, is the information that I got accurate and reliable, right? Like, you look at this and it says, hey, you're off by 4 feet. You're not going to go give this to someone and say, hey, listen, you can build a road based on this data, because it could be way off. So this is going to show you how reliable that is. And maybe give an example of some things you can do with drone data and some things where you really need to get a more accurate instrument for.
So I think drone data is good for quantities and verifying things, just to give it like a rough ballpark. But if you think about like a highway, and we get a drone flight of it, and I want to cut that highway and build onto it, I'm not using drone data for that. Right, not photogrammetry at least. Maybe some LiDAR, but the reason you would use LiDAR in that situation is LiDAR comes with a lot more ground truthing. Think of those as check shots. It's typically much, much tighter, depending on how you do it. You can still get inaccurate LiDAR information. So I think we would probably, at this point in time, with technology as it is, we would not design strictly off of drone data. We typically still send surveyors out there, boots on the ground, to verify critical tie-in points and that kind of thing.
Sure.
Even after all these checkpoints, we would send more guys out there to shoot things to tie into and verify.
Because one of those things that you just for that, you just can't get it wrong. So for project to work, you're not able to move forward if it's wrong. All right, cool. So I think in here we looked at some different scenarios. If you process it just with the GCPs, if you process it with no GCPs, just like sort of your corrected geotagged images, and what those differences look like, and the accuracy comparison. All right. So then you talked about third-party design files, and let's talk about some of the final use cases. So maybe walk through a deliverable for a project takeoff calculation.
Yep. So typically a project takeoff calculation, you're trying to get some sort of quantity, right? Everything in construction is based off of quantities, quantity trackings. Contracts are paid by different quantities, whether that's lineal foot, or in this case, what we're looking at is dirt quantities, right? So you're looking at these colored maps or heat maps, kind of looks like a thermal imaging type deal. Red typically represents cuts, blues represents fills. So when we're comparing that for a takeoff, we're comparing drone data to some sort of design data or even a previous drone flight. So we can say, hey, here's how much dirt was cut out of this area, and in the blue areas, here's how much needs to be filled in this area.
Yep. And so then you're going to basically use that. Don't you guys use this a lot for, especially at the beginning, for estimating what it's going to cost to haul dirt in or out? Or
Yep. So we use it for estimating, and then again, you use that throughout the life of the project, tracking your quantities for, here's how we know if we're on schedule or not, because during that estimate, you go, hey, we've got 10 million yards of dirt that we're supposed to move in, 1 year, which means we should be moving X amount of yards every week. And then you can kind of dial it back from there and look at it at a day-to-day basis for like how much dirt did we move today.
Yep. So you got that. Give us some examples of contours. What are you using contours for?
So a lot of times contours are a great visual representation of is the surface doing what we thought it was going to do. So if this is a finished grade surface, you can kind of see for those contours where the water's supposed to be running based off those. And you can compare those to your design contours or your plan contours. It's a great visual check, and you just kind of look at what you got from the software. Sorry. Sorry. That was distracting. No, so you can kind of see where the water's going and what it should be going. Like, again, a good sanity check is what contours are for. Or if that's not even close to finished grade, you can go, hey, we know the water's going here right now. We're going to have a flood issue, some sort of issue.
Yep. I was going to show one more thing here in a different one. So another guy, Root Patel, he's not here. I was going to get him on this one, but he was in Alabama with some family. But I was going to show real quick. He did contours of a golf course for like a surveyor. It's funny, like engineers were hired. The engineers hired a surveyor, and then the surveyor hired him to go do all the drone data collection. But you can even do contours. Maybe you're doing a construction site, but maybe you need a contours of a golf course because they were having drainage problems, so they needed to see, hey, where are we at on this golf course? What's the current state? Make sure when we're going to go to design this stuff, where our problem areas at. Be able to get, look at these bubbles going in and out. Contours for a golf course. So a lot of different reasons you might need that.
How come he got to wear a sport coat and I had to wear a t-shirt?
He showed up like that, and if you know Root, funny. Root always wears a suit. We literally went golfing one time. It's the first time he'd ever been golfing, and he shows up in a sport coat. I'm like, Root, man, it's like 100 degrees outside. But yeah,
he's a very dapper gentleman. I will say.
That's right. Now, Nate, do you guys ever do like planimetrics in your line of work, or not really?
Yeah. Yep. So like a lot of times, so like for us, when we talk about planimetrics, a lot of times it's talking about just extracting the 2D line work for like existing conditions and stuff. So we get all these planimetric files that we've extracted for like striping, bagged curve, all those things to build just a 2D base map for stuff in the background. We don't do a lot of 3D planimetrics.
I think planimetrics, isn't it all 2D or is there some 3D?
I think it is. I think you can add 3D.
Maybe.
This
was just another example of drone data was collected. This was for a survey job, and they needed planimetrics of all of the building footprint, the parking spaces, roadways, things like that. So they were doing this through a software called Virtual Surveyor. There's so many software applications out there you can use. So that was another cool use case there. All right. This was interesting. So you have your engineering design. You want to talk a little about engineering design versus actual data?
Yep. So like this kind of ties back into those contours too, what I was talking about. So if you look at the picture on the left, you kind of see where the design contours or what the designer's intent was. So a lot of times you have engineers, designers, and they're doing a lot of this in softwares to say, here's what the finished product should look like. And they're creating finished contours. And then if you look over on the right, you can kind of see light gray.
Kind of faint lines here, yeah.
But it matches that engineering design over there on the left. So again, this goes back to just a quick visual check. I can go, okay, that looks correct. That's not way off base. Like, I would be concerned if on the picture on the right, our contours were going the other direction. Right? That means the water's draining the opposite way.
Just imagine, like, I see people with the driveways like going down into their garage, just
Yeah.
basically one of those. Cool. So that's some different is like you said, there's so many different ways to use drone data, and the stuff that you get from it. That yeah. Oh, another one, safety slope. I thought this was pretty cool too. So talk a little about in what scenarios do you guys look at like slopes and safety slope calculations?
Yeah, so OSHA has requirements on safety slopes for if you're doing an excavation, like for every foot deep, 1 foot deep, you have to have a 1.5 to 1, which means like go 1.5 feet horizontally before you can go up another foot. So like you can use this sort of data to check and go, hey, is our slope correct? Do we have an issue? Especially when you're talking about a very large job site, that's a very easy check to go through using some of these different softwares and programs and go, hey, do we see any issues? Do we see any problems?
Yep. Sweet. All right. Well, thanks for that walkthrough. Let me turn this off real quick. So with that, I don't know how many of you in here actually are in this line of work or do these things, but I was going to tell you briefly about those. So we have 4 courses that we made on these topics. Every time we do a webinar, I just give people the opportunity. I always throw discounts in here. So I don't know if any of you are engineers, surveyors, or have like a drone service business who are going to work with engineers or surveyors. But if you want to do this yourself, we have the course that Nate made and some of the stuff I was been showing you. So I'll give you a link to that. We always do deals only for people on the webinar. So we'll send this out after this, and it'll only go to the people who registered for this. But I'll just walk you through briefly what those 4 courses are, what the deal is, the link, and then we'll get into some Q&A here. So if you want to do this, we have something that we created called our Advanced Drone Mapping and Modeling Program. So we created these certificate program, and if you complete, there's 5 courses in the program. The 5th course, I thought it was going to be out by now. We've had some scheduling delays. So we have 4 of the 5 that are out. But they are, I'm going to zoom in here. Can you see? All right, so geodesy for drone surveying. If you're not familiar with the space, you might not know what geodesy is. But essentially, it's how they come up with coordinate systems, datums, reference frames. If you are unfamiliar with geodesy and you want to get into this line of work, you need to become familiar with geodesy to know how you're actually going to be using that drone data. So the guy who teaches this invented a lot of this stuff. Then we have GNSS positioning and survey control. That's talking about all of the correction sources we talked about. I pulled that course up briefly. Talks about how your accuracy, gets into how the satellites work, how that communicates with the drones and the receivers, and how you put all that data together. Then the third one is Nate's course, Advanced Drone Mapping for Construction and Engineering. So we go, we walk through a lot of the course, but he walks you through start to finish his entire process of field work, data capture, processing, analyzing. And then finally, there's one for advanced mapping for land surveying. So that's getting more into the golf course work, working specifically with land surveyors, getting TIN files, doing planimetric work. Basically, if you are a surveyor or going to be working alongside a surveyor, how to use that drone data to get survey products. And then the 5th one, which we have the live recording of when Ted taught it live, but we're working on the nice produced version. It's about halfway done. That one's coming out later, but it's about 3D modeling and digital twins. So we use a lot of bridge 3D modeling for that, which is pretty cool. And I know a lot of DOTs do that, and he does a lot of bridge inspections. So if you want to get in these, the instructor. So Dave Doyle, former chief geodetic surveyor for the United States. I mean, how do you not trust a guy with a mustache like that? Gosh. But he's got 40 years at the NGS. He's a former president of the American Association of Geodetic Survey. Probably the most qualified person in the world to teach a geodesy class. GNS survey control. What are you going to say, Nate?
I was going to say for sure. Definitely.
Yeah. Chris Breedlove. He's GMAX professional for Withers Ravenel now, but he used to do drone consulting and sales for Duncan Parnell. They're a big geospatial hardware provider. And he's a GISP. He's worked with this stuff forever. So he teaches on GNSS survey control. Might recognize this handsome gentleman, teaches the one that we've been going through. And then Roop Patel, he's been in drone industry for over a decade. He helps land survey companies set up their own drone programs and integrate that. So he's worked with a bunch of them, and he teaches that land survey course. And the last one, which is not released yet, is Ted Strazimiri. He's done a ton of different drone jobs. He's a adjunct professor at a college that teaches UAS stuff up in Canada, but he's like probably the most smartest person I've ever met in my life when it comes to 3D modeling. He gets hired out by literally every drone manufacturer that I've heard of to like consult on their products and give them feedback. While we were there doing the training, he got called by like he's been to all these different countries doing all these testing for all these companies and gives them their feedback on how good their drones are and how accurate they are. And so it was pretty cool. All right. So these courses are actually, they count for continuing education. So PDH hours for surveyors and engineers. We went through and we got hours for each one. So Nate, I don't even think you've seen this. Your courses actually counts for 8.5 hours of PDH if you're a surveyor or an engineer. So in total, this is 30 hours, all 4 of these courses. That's about 2 years worth of your continuing education credit if you're a surveyor or engineer. So most states require about 15 hours per year. And some have to get biannual. What are you laughing at?
I'm laughing because I'm an unlicensed high school graduate with no college education. They're like, well, listen to that guy for 8 hours, and that'll count.
Listen, it counts. It is on advancing your knowledge in the field of study.
You just made my ego ballooned up a little bit.
Now, I'll say this. It doesn't count, at least not yet, in these states, because all these states require any providers to pre-register with the state. So we're going to be working on that over the coming months, but that takes application process and time and all that stuff. So as of right now, it doesn't count in these states if you're a surveyor or engineer in these states and you need PDH, professional development hours is what that stands for. But eventually it will. All right. And you're like, sounds great, David. What's all this cost? I'm just going to give you the quick answer. It's expensive because it's the most advanced stuff we sell. But if you use it right, it's worth it, especially on the amount of time it cuts down field work. Like if you are an engineer or surveyor, if you were going to do this stuff manually by hand, you'd collect less data and it would take you Nate, if you were going to estimate how much more time it takes if you were to do this data by hand, like before you guys were using drones.
I don't think you could. So like just going back to the first project we used it on, we ran some rough numbers, and what took us 45 minutes to do with the drone would have taken, I think we estimated 6 weeks for a 2-man crew to get the exact same information at that level of detail.
This is my explosion of my brain.
So to be fair, too, that 6 weeks is only field collection. That's not talking about the office work and QCing it and all that.
Yeah, right. That's where it cuts down the most time.
Yep.
And I think this applies most if you have a survey business or an engineering firm where you're going out and getting these jobs and you haven't implemented drone data collection. I see more like survey firms are picking this up very quickly. So if you own a survey company or engineering design firm or whatever, and you need this type of data and you're like resistant to the technology change, you're now going to be competing with people who, when they're doing their estimating, are going to go, oh, our field work is only X amount of time. And when you have to plan your field work time and budget, it's going to be way higher. And so you're going to start getting outbid by a lot of people because they're going to be able to do this a lot more efficiently. And so it's one of those things, it sounds like crappy to say, like adapt or die type of thing, but it's like being an accountant and being like, psh, I'm not going to use a computer or Excel or QuickBooks, or some type of software. I can do this by hand. Why would I use technology? Like it's going to happen. So anyways, the amount of time you save is wild. Now, if you are not doing any of this work, it probably wouldn't make sense for you to do this. But all right, so here's what the full prices of these courses are. So Geodesy is about $400, GNSS positioning survey control $400, and then the two advanced, the ones on engineering, construction, and land survey are $800 piece. So if you were to buy them individually, $23.96 is what it's listed for on our website right now. But of course, we give some discounts. So since we just came out these 3 months ago, we're still sort of in our semi-launch phase. We've already had, I think we've had like 100 people go through these so far, which is pretty great, getting some feedback on them. But we'll run this deal for the next 4 days, actually 5 days till Friday. So I'll give you the code here in a second, but each one of these is, these are $100 off. These are 300 off. So these are the prices for people who registered for the webinar. But if you want to get all 4 of them together, you get like an extra $300 off. So $1,300 for the entire advanced drone mapping and modeling course bundle. And if you are a surveyor engineer, that would knock out all of your continuing education for 2 years. And you would learn how to save a lot of money on field work by utilizing drones. All right. So that's the price. If you're ready to level up, I'm going to give you the link real quick here. Actually, I'll put it up here so you can see it. It is, if you just go to mappingdeal.com, that will take you to the checkout for the full bundle. All right. And the code that you would use is HEAT. And I did HEAT because I'm in Florida and it's getting very hot now. HEAT 1000 because it's $1,000 off. Maybe it's 1,100 off. I only did a HEAT 1000, unfortunately. So I believe that's right. If that doesn't work, let me know. But I think that's the code that will give you that price. So if you want it, if you're thinking about it, just write this down because this is good until Friday at midnight. That way you don't forget the link or the code. And then if you want any of these courses, you can just go there on our website. It's just go to dronelaunchacademy.com. You can go to courses and you'll find these. The promo code for any of these is, I made it simple. It's just HEAT, and it gives you these discounts, the 100 off of these and the 300 off of these. It's the same for each one of these. Okay. All right. So those are the deals. If you want to get them, if you need your continuing education or you just want to learn how to implement drone workflows and get all the knowledge from all these folks, and get these certifications. Each one of these courses comes with its own nice little certificate that you have. It's like it's on this little independent website where it shows what you did. You have to pass an exam with an 80% or higher at the end of each of these courses. And if you do, you get your certification for that topic, and you get your continuing education credits too. All right. So, and you get something that looks like this. Where did it go? Where'd the little certificate guy go? Oh yeah, here. So you get something that looks like this for each one. And so people can validate that credential that you've passed that exam for each of those classes. Anything else? Oh yeah, you click a little button, add it to your LinkedIn. So you can go, hey, I got a certification in this. Especially if you're a drone service provider, you're trying to do this for someone and maybe you don't have a ton of background to go off of. At least this gives them confidence that you have a baseline knowledge in survey control, GNSS, because that's a problem with a lot of drone service providers is they get into it and they think they're going to go work with all these people and they have no idea about all these topics and they end up kind of making themselves look silly. And so, make yourself more valuable to them or your employer. All right. With that said, let's get into some Q&A. Yeah, Q&A time. Do you have any questions? I only got about 40 people on here, but if you guys have any questions for Nate, drones, surveying, engineering, mapping, fire away. We did have one said, how does this apply to existing buildings on site? I'm not exactly sure what that was specifically applying to, but do you guys maybe ever do 3D models of buildings, or is there any special consideration for buildings?
Yeah, so a couple different things. So if you've got buildings on site and you don't want them mapped, so a lot of times, depending on whatever software you're using, you can filter those out. It essentially flattens out the buildings. The other thing you have is if you're using, so most drones like the Wingtra, so the Wingtra we're using has a nadir, right? So straight down. But you can use oblique angle drones, oblique angle cameras, and get what's called vertical face imagery and actually make 3D maps of the buildings as well.
Cool. And Wingtra does have at least slightly oblique angle camera. I think it's like a 10-degree.
I think it was the Map 61.
Yeah, I used it the other day. All right, what was your first drone you used to make money, and what gig was it / type of gig? Well, Nate does this for his employer. I can answer this for Root, who has more of a drone service business. He's done a lot of stuff with us. He started off, I believe it was with like a Mavic Pro. That was somewhere around, maybe it was a used Mavic Pro. I think at the time it was $1,000. I'm trying to remember the story. He told it a long time ago. I think he had an Inspire 2 he was trying to use, and he wrecked it into a parking garage. And so then he had to go out and buy a used Mavic Pro, and then did some mapping for some insurance companies, and then mapping for some insurance companies. And I think he ended up made like 10 grand with that. And then he did another job for like they made power lines, like the actual power lines, the materials, and they had just these giant coils of inventory, like the actual power line cables, and they had it scattered all over the place. And they're trying to reorganize their site, and they wanted an idea of where everything was, how much space they had to move it around. And originally, I just wanted him to take some pictures, but he sort of explained photogrammetry and mapping to them, and so they hired him for that. And he flew their site and helped them do inventory and move all the stuff around on their site. And I think that led to, $8,000 worth of work, I think he said, over several months. But now he does stuff for survey gigs and makes some pretty good money because of the time that they save on field work. Anyway, surveyors can charge a lot because there's not a lot of them. So they have some budget to work. Explain the difference between 2D and 3D contours or mapping. Contours are always going to be 3D. But you want to maybe talk about the difference between 2D and 3D?
Yeah. So contours have 3D information in a 2D format, if that makes sense, right? So it's going to tell you this is the elevation 1, this line is elevation, 5, this line is elevation 10. You see that in a 2D format. Typically, you're not going to see 3D contours unless you're looking in some sort of digital software where you can actually rotate. So those contours inside of a CAD program or on different platforms actually have those elevations, so you can rotate the view and you can actually see the map.
Trying to see if I can pull up some of the Wingtress stuff we did. So I'm gonna I could show some 3D data here. Let's see here, view map. Let's do another one, and I can pull that up. What's your recommendation for post-processing program?
That's a loaded question. So I think, honestly, if you're wanting cost-effective wise, I think right now there's I think Pix4D. I don't know if it's Pix4D Mapper or Pix4. I think Pix4D Mapper is a little cheaper than Pix4D Matic. They both do a little bit different thing. I think it's Pix4D Mapper is $350 a month or almost $3,000 a year. But then there's what is it at Agisoft Metashape Standard? That's $179 per upload, or was it $3,500 a year? And then you got Drone Deploy. So it depends really, because if you're looking at every once in a while, I would do one of those pay per upload things versus buying a $3,000 or $4,000 license for the year. Same thing we use Propeller. Propeller is good for if you're doing mass processing and you're going to do a ton of it, super cost effective that way. But if you're only going to do it every once in a while, it's probably not the route you want to go.
I'm trying to find, well, it's not working viewing wise. I was going to try to show you 3D data in Wingtress Cloud. But, this is a good question. Combining mobile mapping with airborne LiDAR, how accurate can it get down to?
That's a trick question, Carl, and I don't like that you did it. No. So really, there's absolute accuracy and relative accuracy, right? So relative accuracy is kind of super accurate within itself. A lot of times you'll see, hey, this is accurate within a centimeter or half an inch, but that's floating around in the world, right? And then you have absolute accuracy, which is you take that, it's accurate within itself, within half an inch, and lock it into the world, which may still be an inch or 2 inches off, right? But you're half an inch accuracy within itself. So I would say with LiDAR mapping, with photogrammetry, anything like that, whether it's mobile or aerial, It's all got to do with how you tie it in with your ground truthing, your GCPs, and your survey control. So we've seen more issues when we deal with those kind of things from poor control than anything else. That's why I say it's a trick question, because it really depends on what you're using to tie it down to.
So here is someone was asking about like viewing like 3D data. So if you were just to look at the ortho, this is we did an Orange Grove flight with a Wingtra. And so like you can see here are like ground control points placed around here. And then your digital surface model, you can take a look. You can see there's not we're in Florida, so it's not like a ton of elevation change, but it definitely goes downhill. I think someone was asking about contours. So this would show the contours moving downhill here. So they're actually taking this Orange Grove and they're demoing it, and they're going to turn this into like a planned community with a bunch of houses. So again, with photogrammetry, you can only pick up what you can see from the air. So when you have tree cover and stuff right here, it just looks like this weird drape. So if you're going to try to get the bare earth underneath here, you'd either have to get LiDAR or you'd have to sort of cut around it, and the software mapped like kind of interpolate between those points. But it was good enough for them to get the data that they needed. Then you could do point cloud. This might take a while to render. Actually, that's not too bad. So this is the point cloud data, which literally takes all of the pixel points and plots them. And you can see that's like populating. I'm not sure how good the quality is for you guys, but you can see, and Nate was talking about having to get those ground control points in your imagery. I can show you. This will populate. Here we go. So if we zoom in here, we can see as these points populate. You can see here was our ground control point here. These points will get denser in a second. All right, we'll answer questions as we go. All right, let's see. Oh, he also added using GCP and ground truthing. What if you're doing surveys of existing buildings? What's a good drone to do that with?
Again, I think it goes back to, like, you can do that with most of the DJI drones. I think almost all of them that are doing mapping. We first started doing vertical face imagery with the Phantom 4. All the way back then, it was doing it. So anything that does, it's really not about the drone necessarily, but it's about the angle of the camera you can get on the drone. Yep. So if the drone can do photogrammetry or LiDAR, and you can aim the camera at that vertical face, you can do it.
Can you get, RJ splits this into two questions. Can you get contour maps from photogrammetry flights?
Absolutely. Yep.
You can see here, this was photogrammetry just straight down, no angle on the camera at all. And you can see from here that we were able to get the contour of the earth, and you could turn this into, if you go to files, you can have all these, and you can export like your point cloud or your DSM, and then you can pick the points you want and turn it into a contour. All right, let's see. I skipped one. Jeremy, what did you do for employment prior to the drone game? Was drone operating a side hustle? I don't know if this is aimed at you, Nate, or me.
Drone. I've been surveying for 24, 25 years now. Before that, I was a degenerate. No, not really. I was just trying to. I got into surveying trying to figure out what I was going to do with my life, and stumbled into it. Funny story. First day on the job, kid you not, they asked me, got called in the office. I was working at a temp labor place. I went from high school to started as a cashier at Walmart, got bored there, and was like, Can I go gather carts? Because I don't want to stand here. And they were like, you want to go push carts? And I was like, yeah, standing here dealing with people is terrible. Was a concession movie theater manager for a while, Baskin Robbins, and then started working at this temp labor place, day labor, because I was trying to figure out what I wanted to do with my life. Eventually got asked to go. They said, hey, you show up every day. Do you want to go work for this guy who's looking for a full-time person? doing surveying, and I was like, I don't know what that is, but sure. So I went there, and the guy asked me. This is very embarrassing looking back, but again, I was like 19, 20 years old at the time. He said, "Hey, do you know what surveying is?" And I was like, "Yeah, it's like you call people on the phone and ask them questions." He's like, "Absolutely not. That is not surveying." So just recently, probably around 2017, 2018, was when I started getting into drones. So really, drones have kind of become my side hustle. Started as part of my job. David and I kind of met on LinkedIn. He reached out to me, started talking, and got into doing this.
Sweet. Yeah, Nate's been a huge help. It's really cool to see someone from like I'll call it the enterprise perspective, like how a big company is implementing drones. I mean, big companies are just made up of a lot of individual people who are out there doing projects. So it's just cool to see, with the resources of a big company, how they think about it strategically, all the way down to, the company Root's working with right now is like a probably 5 to 7 person. I don't know, depending on I don't know if they have part-time people, but let's say 5 to 10 person survey shop. That's kind of like local Central Florida and how they're implementing this and doing this right now. So now they use drones, I think, on almost all their projects, no matter what the size. Sometimes they'll rent like a M350 with a LiDAR unit on it to do a job. Sometimes they'll just use a Mavic 3 Enterprise and go throw that out there. But every time they are using drones now to collect that data and getting that set up. So let's see. We got another question. Discuss use of LiDAR photogrammetry for canopy coverage on topos. Is LiDAR better, more accurate? Answer on ground elevations and canopy and ground cover. For sure, LiDAR is better, right?
Yeah. So like the big difference between photogrammetry and LiDAR, if you think about it, is like photogrammetry only gives you surface on what you can visually see. So
this was a great example, I think, right here, what we were looking at.
Oh, yeah.
Sorry, keep going.
So like LiDAR can penetrate vegetation because it's shooting multiple lasers. Pew, pew, pew. Sorry. Apologize. So you get a more accurate representation of what the ground is doing because even though you're picking up, like when you look at LiDAR, you'll be able to see individual leaves and that kind of thing too, but there's so many lasers being shot so quickly, it's penetrating and missing a lot of the leaves and still picking up ground information. So that's where you get like your noise and that kind of thing. So you'll get a ground surface, but you'll get that vegetation too that you can then take out and get that actual existing ground. Now, photogrammetry, say if you look at terrible example, real world example, use photogrammetry and say a cornfield that nobody's cut the corn on and the corn stalks are 4 foot tall. Guess what? It thinks your ground is 4 foot tall because it can't penetrate that grass.
Well, it's just like this. These are small orange trees, and if you look, it'll appear like you get all these little mini hills here.
Yeah, that's perfect. Because like LiDAR would, if those trees were solid all the way across, well, I say solid, but like not super dense. Because that's the other thing too is like LiDAR still cannot penetrate complete 100% canopy coverage, right? It doesn't go through vegetation, it passes through gaps in the vegetation. If that makes sense. So like LiDAR would get you down to the dirt if there were solid trees and no gaps in there. Photogrammetry, you are going to get the tops of those trees like you see there.
Yeah, I mean, and this was fine for them because obviously this is relatively flat. You can say, take this point here, and tie the surface between them, and it's that's where the ground is because that's just a little single tree there. But it would get maybe a little bit more complicated if you were to go over here per se, right? Where there's like pretty thick coverage. You don't exactly know what the ground is doing under here, as well as you would with LiDAR. And then even in here, this just sort of gets a little swampy. So, but yeah, that's where LiDAR is a lot better. All right, let's see here. Not a licensed surveyor, but I want to get into photogrammetry, 3D models, etc. Who should I target and what can I offer them? I don't know, Nate, you have any input on this? I can give some thoughts.
So I know we've talked about this a couple of times before, and I think I would target engineering firms as a good one. uh, like mid-size engineering firms, right? You're
Yeah.
typically your larger firms like a Kiewit, we're going to perform a lot of this ourselves. However, in a bind, if we are short on staff or whatever, we will sub that out. But I think your mid range to low, like your mid range, low range, smaller engineering firms, design firms, and maybe even surveying firms may not necessarily have this. So, like, you could work with them to sub out and use, get that information to them to perform, get done what they're needing to do.
Yeah, that's basically the people that I know that are doing this well are at that exact level, like smaller to mid-range engineering and survey firms. Because I think about it, they're not going to probably have this knowledge or capability in-house, and so if you can work as a consistent, reliable subcontractor for them and basically help them with a lot of their field work, then all they're doing is sending out their survey crews to shoot ground control points and collect check shot data, and then you're providing them with all of the aerial data that they're going to combine and use. So they're still able to have confidence because their survey crews are going out there typically and shooting those control points, and they're getting their benchmarks and all that, so they feel good about the accuracy with their teams. But
And I would say too, like if you, it's gonna sound weird, so like we did a small project up in the Texas Panhandle recently, and you know, it was a 6.5, 7 hour drive closest to like our closest pilot, and small project, small crews out there, but they wanted drone flights. So we started talking and seeing if we could find anybody local to save that travel time too. So that's another thing too, is if you see projects ongoing or construction firms, it never stops to stop. It never hurts to stop and ask, like, hey, are you guys doing any sort of mapping, any progress photos? Do you want that kind of information? I can provide that service because a lot of it is really about networking and reaching out there and talking to people. Because the other thing is, like, we'll have people that'll cold call us, just walk into the office and be like, hey, you guys looking for this? And we may not be looking for that service at the time, but we'll go, hey, these people might, these people might, these people might. So start building that network too, and then your name will get tossed around.
Yep. And I know I was just thinking about actually another friend of mine who wanted to use the Wingtron. He's got a 3,000 acre site that they're developing communities on. So especially like civil engineering firms and like earthwork companies, like they have to do a lot of this estimating and progress stuff, and so they do a lot of progress update flights for those types of companies for like really large areas. And then they actually even, those companies said, hey, can you actually give us elevation data? Because we want to make sure that each of these, they're grading lots to build on. So like they're doing all the earthwork prep so that then people can come in and pour foundations to build houses. And so they're like, hey, can you guys give us elevation data to make sure that these are all level lots? And they're like, ooh, you're getting into like surveyor territory there. But they were able to just partner with the survey firm to come in and collaborate on that data with them. So a lot of times you can end up working together. Is it better to invest in mapping software or map processing software? Maybe are those the same thing? The entry cost is steep to learn and test out software with good flight planning and map legitimate 3D models and point clouds. Something you could do is if you have a computer that can process locally, a reality capture is a software, and it's free and it does fantastic 3D models. Also, a lot of these software platforms will have free trials. One of them that's I think a good one to get into if you're cool with cloud-based stuff is Pix4D Cloud. I think the base version is only like $50 a month or so. Now it doesn't allow you to do GCPs, but it allow you to do like all the ground controls, or allow you to do all the regular photogrammetry mapping. If you do want to do GCPs and you also have a computer virtual surveyor, runs locally on your computer, but it'll do photogrammetry processing with GCPs and all the stuff, and I think that's like $150 a month. So relatively speaking, those are decent entry points. If you want to go really not high level, you can do some like pay-as-you-go type software systems so you can check out Maps Made Easy. It's not as powerful of a processing engine, but you just like buy credits. And I think I mapped out like my house or pretty decent sized thing, and it cost me like $3 in credits or something. It's pretty cheap to test out with. Or another one you can test out is Birdi.io, BIRDI.io. They're an Australian company as well, and it's a similar pay-as-you-go type thing. I haven't used them in a little while, but I remember looking back and it was pretty cost effective if you're on the learning end of things. So a lot of options out there. All right, I'm very interested in the course, especially since I'm doing self-study out for my PLS. Cool. Currently working as a survey tech. Also got my 107. Sounds like you're on a nice path. Can detail how this will make me a better asset for my employer that is still stubborn on having 4 two-manned field crews. Nate?
So we struggled with this even at Kiewit internally. I think one of the most important things is if you're working for someone that you're trying to get involved in this or trying to get started into not just this, not just drones, but any sort of new technology as it's coming out, especially as it's moving so quickly. So just learn to speak their language. What do most people at the top care about? Money. So, yeah. So it's being able to really make that comparison of like, hey, you start getting into stuff like man hours, right? So like just doing a rough business case. Go, okay, 4 two-man crews, that's 16 hours a day. Me doing it by myself in a drone, that's 2 hours of data capture and 4 hours of processing. So right now we've shaved off 10 hours of cost,
Well,
right?
even if you're capturing by hand, let's say you're like field crews go out in there and stuff, you still have office work to do. I mean, even if it's maybe
Right.
not as much photogrammetry processing, but you're still having to put together like a tin surface, right?
Yeah, and if you think about like even a 4 two-man crews are probably covering 5 to 10 acres a day. Drone, you're getting 50 to 100 plus acres a day, depending on the drone. So right there, you've just 10 times production for the data that you're capturing and getting in. And then if you throw in safety as well, safety risk of having people walking next to traffic, getting topos or over rough terrain, that's a pretty high safety risk. With a drone, there still is some risk, but it's not as high. And again, we've kind of taken on with a lot of the technology we're using is we would rather have that technology risk of I don't care if a robot or a drone gets wrecked versus a person, right?
Yeah.
I can protect a person and they don't get a sprained ankle. I'm going to use a drone, right? So I think that's part of it too. And if you think about like redundancy and QC type fields, the risk is pretty high. Or you've got a lot of manual rework there versus if you're using a drone, you've got a digital archive and that kind of thing too, and you can reprocess if you think there's a mistake and that kind of thing. So if you made a mistake during a field topo or field collection of data, you're sending the same 8 guys back out there to redo it.
Yeah. When you're talking about safety, I heard the other day of a surveyor got hit by a car. He's on close to a highway, getting some data, and it's like it can be dangerous. You're working close to traffic and equipment, so yeah, less time you can have people in dangerous spots. Better.
And I think part of it too is like you pitch it internally is go one is started on a low risk job, run the drone and the processing software, present. One of the things I've had to do internally is do the drone stuff and then do the exact same work the same way, old school, and go, hey, I was done in half a day. This took the guys 4 days to do this. If you scale that out, you can easily see like where you're going to get cost savings for. And then, and again too, it's about communicating. We're not cutting crews. We're keeping them safer, making them more focused, giving them better data, being more efficient. So it helps us close the loop between data collection, CAD, machine control integration, and it turns a lot of the surveying aspect into very, instead of reactive, we can be more proactive by getting this information faster.
Yeah. And if anything, most survey companies I know like are turning away jobs because they're just too busy because there's just a shortage of surveyors.
Yep.
So for the ones I know that are using it, are like, oh, we can speed up this field data collection process and bid on more jobs and get more jobs. Like, let's do that. It's not like they're cutting people necessarily. They're just actually able to get
Yep.
the work that they can get. I was gonna say too, another thing, it's like not like you have to, like Nate was saying, kind of starting small, just doing the drone work alongside the manual field work you would do anyways. If you're going out there and already shooting points, then you're gonna, throw some GCP targets out, shoot those as well while you're out there. If you're already getting it, you can rent some of these drones like a Mavic 3
Yeah.
Enterprise by the day for not that much. Go ahead and throw it up in the air while you're out there. If it's not that big of a site, you capture it in 30
Yeah.
minutes tops.
I think the big deal too is like talking about this, Mr. 25. Yeah. Is you're going to have to sell it internally and like make sure you're speaking the language, which is we can save costs, we can increase efficiency and effectiveness. To David's point, like we can take on more work by doing this, which gives everybody more money.
Yeah. And you can like have all your check shots and be like, listen, you can see if it's accurate or not. Just, feed it into the software and see what it spits out. Jeremy asks, have you ever participated in search and rescue operations with your drone, Nate?
No, I have not, but they've got some super sick ones out there that do like the thermal imaging, the night vision, the infrared. Like, I'm always trying to get us to invest in buying those, but sadly,
Hard,
we do not have use cases. And they're
hard
like,
sell.
wow,
Yeah.
yeah. Same thing with that one that shoots a like 25 foot of flame.
Yeah. Hard pass.
That was a actual. That was like a hard no. It was like absolutely not. And I was like, hey, you can check it out on YouTube. There's just like a little. I think it's got a 1 gallon gas tank and it shoots this jet flame. And I was like, but look, they're cleaning out like birds' nests and wasp nests and stuff. And they're like, absolutely not.
Your previous pitch was about safety, and then you bring this drone into it. I will say with search and rescue, I have a friend who worked for like a energy company, and they were deploying some stuff after a big storm, looking at like assessing damage. And while they were out looking around, it was stuff flooded out, and they like, oh, that's somebody trapped on their roof. And so they were able to go find some emergency responder folks and be like, hey, these people need a boat to get off their roof. And I think they were actually, I may be making this part up, I remember them saying they were able to like bring them some supplies on the drone, at least some like bottles of water or some stuff. So that's a pretty cool use case. I also know another instance. I interviewed this guy one time, part of a fire department. It was nighttime. This kayaker went missing. It was pretty cold. He was on this river. They couldn't find him, so they sent out like I think it was fire and police department went looking for him, and it was pitch black. They couldn't really see anything. Like, yeah, we got on this bridge, tossed a thermal drone in the air, and immediately saw this guy hung up in a bunch of like trees on the side of the river. And so they're able to communicate with their ground team of people walking, and they were able to just on walkie-talkie say, nope, to your left, to your right, 30 more yards in front of you, and guide it right to the guy who's missing.
Well, so we're started looking at the Skydio X10, which does a bunch of photogrammetry and stuff too. And like Skydio's got a bunch of cool stuff that you can add on to the drone, like parachute, spotlight, and speaker.
Yeah,
And
yeah.
so we looked at that for like a build out for safety, and it's like, hey, you could use that to communicate. You could do night operations, that kind of thing as well.
Yeah. And that might be for the other conversation. I do, if you're trying to get thermal use cases, Nate, I thought that they used thermal on bridges to look for like delamination and stuff. I'm just making up words maybe, but you could toss that out there. That's what I heard somebody say. Like, looking for the layers of the bridge, or like looking for like different moisture penetration where it shouldn't be on bridges. So
yeah.
Let's see. Ooh, this is a good one. Well, actually, sorry, maybe we'll go do them in order. Work as a civil designer, use AutoCAD, Civil 3D every day. Do you know of a way to utilize drone data in AutoCAD, like point files for building services?
Yeah, so this is pretty common across most CAD platforms. So like AutoCAD, Civil 3D imports point cloud files. So that's your .las, .las. I think they do LAZs as well. I know
Yeah.
they do XYZ, they do .pts files, which are pretty standard exports from a lot of the drone softwares. You can get in your DEM, DTM, DSM, raster surfaces, TIFFs, images, bring in 3D break lines, contours, tin files, your ortho photos. So all that stuff works pretty seamlessly with AutoCAD Civil 3D.
All right. Let's see another one. Mr. 25, you're welcome on behalf of Nate. Most of the answer. Are there any free programs you can manipulate a demo model / point cloud and try out software? I feel like most of them offer free trials and like demo project data,
Yep.
but do you know any specifically, Nate?
So almost all of them do. And I would say something I've learned too is like these vendors want to sell stuff to you. So tell them, I want a demo. Show me how to use this. Because a lot of times FAD comes free with a lot of purchasing. Like, don't be afraid to ask. I know Propeller's really good about it. Datamate, um, Pix4D, all those guys. You can reach out to them, start contact. Like that contact sales is like it's gold. Use it. Tell them, hey, I'm thinking about doing this. Here's my plan. Bye. I've heard this software is better than yours. Prove it's not.
Yeah.
But like, seriously, ask these guys for demos. Almost every single one of them has some sort of demo program, some sort of demo data set that you can get your hands on and play with.
Yeah. I was gonna say too. Well, I can't guarantee this, but I know most of them. If like you're using it, I've done this before. I'm like, hey, I'm still messing around with it. Can you extend my trial? They're like, sure. So they'll only do that maybe once or twice. But what are you laughing at?
I'm laughing. God, I'm laughing at Jason.
Jason, this one.
Yeah. So it's either one of the facilitators or the students in the training we did because we had a big session on how to approach the bear.
Approach the bear. I don't remember this.
No. For the school I'm
for your
right, like today we talked about that. So people were like, "Oh, we're gonna ask you about approaching the bear on this thing," because I told them I was doing this. I was like, "Good Lord."
That's how you know. All right. Oh, there's another one here. My employers asked, talking about how the tree industry is starting to use drones for utilities and tree risk assessments on difficult terrain. Oh yeah, you're talking about for like vegetation encroachment on power lines and stuff, or are you talking about something else?
We used drones for environmental up in Arkansas. So like there's some very strict rules depending on what season it is, that kind of thing as well for like bird's nest. Like if there's uh, eggs in the nest or baby birds in the nest, you can't remove trees on the construction projects. A lot of projects can get shut down portions of the project because there's birds and that kind of thing. So we actually used small drones and flew up, put it in sport mode, so it turned off obstacle avoidance. I just looked at the screen and we had a spotter, and we went up there and we checked out birds' nests in these trees to make sure that it was okay for us legally to remove these trees.
Another thing. Hold on a second. I'm responding to a comment here. Another thing, I think you were asking tree risk assessment. Yeah, so typically for that, I know they use it for tree inventories a lot of times. Well, so actually several different things. Look at tree canopy sizes. So they've got some cool AI software that will also like, I haven't used it personally, but I've seen it like, everybody talks about on LinkedIn, like, oh, look at this cool software, what it can do is so like do photogrammetry, and AI can pick up on like different canopy sizes and volumes of trees if that's what you're trying to measure. I'm not an arborist guy. Actually, Chris Breedlove, who teaches the GNSS course, started off at he's a certified arborist something. So he was using geospatial stuff to do tree inventories and tree surveys. So they'll use it for tree surveys. I know they'll do it for like canopy volumes, but then specifically for utilities and power lines, they'll typically fly LiDAR because the power lines are, they're thin and LiDAR picks them up best to see where they might need to trim trees back so that it doesn't, mess up the transmission lines. So they definitely use that all the time. And they used to do that usually, I believe, with helicopters, and drones have replaced a lot of that. And now that they're changing the beyond visual line of sight rules any day now, they have some pretty cool drones, obviously more expensive, that can fly, miles and miles without, because you can go further than beyond visual line of sight and it can collect all that data. So that's going to make it way more efficient for them whenever you're doing like corridor based stuff. So highway, power lines, pipelines. Like I've got to fly in this 100-yard wide area, but for 6 miles, that's where the beyond visual line of sight stuff is going to come in a lot of.
When I know too, like with a lot of the drones, they have that what is it, like NDVI multispectral stuff. So like a lot of that you can use in vegetation for like tracking health and stress levels on trees. I think they're doing that right now in a couple different things I was reading about.
Yep. A lot of the plant health gets the different, the multispectral cameras can pick up the reflection of different light spectrum, which indicates, plant health, and they can use that to do their crop spraying. I'm not pretending to be agronomist or anything, but I do know that that's a big use case that's picking up a lot. And crop spraying, I know that doesn't have to, well, it's related to photogrammetry because you'll maybe do photogrammetry, do the analysis, and then it's still same type of flight planning, automated mission planning to then do like more targeted precision agriculture spraying. I know that's picked up a lot in the US. I think people thought that was going to catch on way earlier, but I feel like it's just now catching on more and more with all these different T50 Agris drones that DJI came out with and a bunch of other companies are coming out with. That's expensive to get into, but we do have a podcast episode, Drone to 1K, with Brandon Beal, and he has a business where all he does, I think it's called Aerial Elevation Application, something like that is his company name. And he does he sprays Christmas tree farms and a bunch of other row crops and stuff in Virginia. So that's a cool one to check out if you're interested in that kind of stuff. All right, we're winding down our time here. I don't want to, keep Nate here all night, or also you guys seem to be out of questions for the 27 of you who are left on here. But yeah, thanks everybody for coming tonight. Again, if you're interested in this stuff at all, just, write down mappingdeal.com or the promo code HEAT. This will be good till Friday at midnight. And if you are a surveyor or engineer, just a reminder, you can get 8.5 hours listening to Nate talk about drones.
That's ridiculous.
And not just listening. Each of these courses comes with a full textbook, somewhere between 100 and 200 pages each, that we put together. So you get all the videos of everything they do. Plus there's quizzes throughout, there's a final exam, and then there's a textbook to read through as you go through it. And you have lifetime access to all these courses too. So should help you if you're in these fields. Also, if you're just like very beginning, we do have the drone mapping modeling fundamentals course, which just teaches you about photogrammetry. It does a lot more of the simple things that are leading up to getting into this. So that's not necessarily what we're talking about tonight, but we do have that too. Cool. Thanks everybody for coming out. Oh, yep. Cool. You passed 107. Nice. Awesome. Well, thank you everybody for the great conversation, asking good questions. And yeah, feel free to hit us up if you have anything else. Try to get Nate on here again sometime in the future, but love doing these. And
yeah, from you all. Thank you guys. Hit me up on LinkedIn.
Yeah, on LinkedIn. And
that's about the only social I'm on.
Okay. As long as you don't regurgitate ChatGPT content on LinkedIn, that's driving me nuts. When you read something and you're like, what in the ChatGPT are you saying? People will just put a prompt in and they'll be like, it's not just about safety, it's about efficiency. I'm like, that's 100% written by ChatGPT.
You know what gives it away is the little emojis and the icons and the M dashes.
Yes.
I'm like, you see that, that's more than likely AI guys.
I'm like, just at least rewrite it so we don't know. But whatever. Anyways, but I like, at least Nate, I didn't see any AI generated content on Nate's profile, so I knew he was legit. So cool. All right. Well, thanks again, everybody. Take care. See you on the next one.
All right. Thank you guys. Bye.